Yes. Good morning, all. I am Miklos Antic. I am the President of the European Geothermal Energy Council, and we welcome you to this webinar, Green Recovery and Oil Crisis, a window of opportunity to invest in geothermal. I see there are still attendees coming online, so I suggest that we wait a couple of minutes before starting up with the discussions. Well, in today's agenda, we are, I will give you a short introduction of the topic. Then we are welcoming industry experts from service companies, Damien Thiollet from Schlumberger, Eric L'Autre from Vermillon, and Alberto Gentile, Deputy General Manager of ES Geothermal. Then I would stimulate everybody from the audience to raise their hands to ask questions or speak live to have a stimulating discussion regarding to this topic of how this oil crisis could be an opportunity for the development of geothermal. First of all, I just want to speak 2 words about EGEC. EGEC is the European Geothermal Energy Council, is a non-profit organization founded in 1998 to promote the European geothermal industry and enable the development both in Europe and worldwide. We are involved in policy, in improving business conditions and driving research and development. It's an industrial organization with 120 members from 28 countries. And we call ourselves as the voice of geothermal in Europe. Our team, located in Brussels, is very active in contributing to the visibility of geothermal in the by lobbying among the European organization and Commission in order to make geothermal visible. Well, the current oil crisis brought us to a way of rethinking our way of life, because everything has been stopped almost all over the world. Consumption of energy, especially fossil fuels, has been dropped dramatically because transport has been reduced to the minimum. And this also had a tremendous impact on the oil prices, and which have dropped dramatically. Geothermal energy is often regarded as the oil of the poor. Well, geothermal shares both exploration and exploitation risks, and geothermal is produced by technologies deployed currently by the oil industry, as drilling, as geoscience, drilling production technologies, which are more adaptive. Well, geothermal has been brought quite significant contribution also to the development of oil industry by developing high temperature tools and high temperature equipment devoted to such environments. Well, of course, we believe, as EGEC and not EGEC, as enthusiast geothermalists, that geothermal is a sustainable alternative to fossil fuel. And within this stream, we see that all over governments and also at the European level, there is a big drive to decarbonize the economy, to make it greener, and to use less and less fossil fuels to our daily needs, such as heat, which actually represents 40% of our energy needs in Europe. for this, geothermal is representing a strong alternative because it can be deployed from a small scale, from shallow to very deep. Electricity is also a good production resource from geothermal, and more candidate sites all over Europe and continental Europe are eligible for producing geothermal. Another co-production element from geothermal is lithium. And lithium, in a study which has been published recently, could represent 10%, for instance, of France lithium carbonate needs for batteries, because this would drive more the automobile industry versus to electrification. So all in all, we see that as there is a synergy between geothermal, because geothermal is strongly depending on technology coming from the oil and gas sector, geothermal is a great opportunity to be developed, taking advantage of the fact now of the downturn of the oil industry, because there are less rigs operating, and now but there is a big impetus of developing geothermal all over Europe. I finish here my introduction, and today's discussion I would like to stimulate it on the topics like resource, risk sharing, technology, and also market opportunity of the oil sector in geothermal. So I would like to pass the word to Damien Thiollet, who is European Geothermal Business Development Manager at Schlumberger, to share his vision of Schlumberger regarding geothermal in Europe.
Yeah, so good morning, ladies and gentlemen. So Valeria, if you could give me the hand for the presentation, please. Okay. So I will share with you a few slides. So as I said, we close. So my name is Damien Thiollet. I'm the business developer manager for the geothermal market for Schlumberger. I've been with Schlumberger for 7 years now. I started to support the artificial lift division, and now since 2018 I support all the product line of Schlumberger for geothermal project in Europe. So I will make a very short introduction of Schlumberger. I will not go into much detail and to present to you all the product line services of Schlumberger, but just a very short introduction, and then I will make a transition to the topics that we are interested today. So go to the next slide. So okay, so here's just a very short presentation about Schlumberger. So Schlumberger is a world leading provider of technology for the oil and gas industry. We are specialized in reservoir characterization engineering, in all the possible drilling services, and in production processing of oil and gas. We provide a very large range of products and services, so the largest one versus competition. We were founded in 1926. We currently have around 100,000 people worldwide. We have 140 plus nationality represented at Schlumberger, and we cover more than 120 countries. On the right side, just a few figures to show how is the revenue contribution from the different area. Okay, so of 2018, but nevertheless, it give a good it's still a representative, I would say. So we see that the revenue is really spread all over the world in the main area of the world. And also regarding the nationality mix of Schlumberger, again, so all the different world area are very well represented. So I said I will not cover all the product line and services of Schlumberger, but I want to focus on one, let's say, activity that we call integrated services, because this is something that we want to offer for the geothermal market that we will talk about today. So Schlumberger integrated services mean that we provide turnkey wells drilled So we for sure started this activity in the oil sector, where we have large field with a large number of wells to be drilled, so that make it easier to mobilize equipment, resources, etc. And how you can see here in figures, so we have been involved in more than 350 projects, more than 10,300 wells drilled, and 68 million footage drilled. So it means that we acquired very large experience and expertise in drilling wells, so in offering turnkey wells drilled. We are making this transition to geothermal. I will take a bit about it a bit later on in my last slide, but we want to bring to the geothermal market this expertise of drilling wells that we have acquired worldwide. But for sure, we have to adapt to the geothermal market. So we have to go with, let's say, lighter, let's say, structure to be competitive on the geothermal market. We cannot come with exactly the same equipment technology structure as we use in the oil sector. But that, let's say, a trend. Okay. Then my last slide here is about the current trend to positive impact on environment. So due to the let's say, climate changes and the current crisis and the last crisis, so all the oil company, oil service companies, so have to move to renewables and to environment, say, respect, etc. So then we organize our this trend and this activity in 4 pillars, if I can say. So on the left side, you see what we call stewardship, so taking care of environment footprint, etc. And we do it for Schlumberger, so meaning that we in our activity we are trying to reduce our environment footprint, environment impact, but we do also for our customers. So we develop tools and services to support our customer. So in let's say reducing environment footprint and in let's say improving the environment, social and governance objectives. So as an example, okay, we decrease weight, decrease water and energy consumption, lower emission, and optimize the use of the resources. There are some, let's say, way we do to improve things. And then let's say the trend on what we are developing, product or services. So has been split it in 3 pillars here. So decarbonization, we are developing new products in the low carbon technology. The one I will talk more about is adjacent business, so especially geothermal. So here in geothermal, we currently have 3 different way of development. We have one project that is called Celsius. This project is developed by our R&D department in Clamart, next to Paris. A team here is developing heating and cooling solution for buildings and campus. So meaning it's not for private housing, it is not for district heating, but it's there for intermediary solution with such a certain size of building and or campus. And the technology used here is multi-deviated shallow wells. So the idea is to have a reduced footprint at surface, and from there go with deviated wells to capture the heat on very larger area underground. So in here, Schlumberger is bringing so all this know-how in terms of underground knowledge, so and then drilling technology engineering. So this team made already one pilot wells, and they are now developing a pilot project for one of Schlumberger building, so in France, and we can expect that in 1 year from now, more or less. So this project now will move to a commercial solution. Another line of development is carbon capture. We developed a solution to re-inject CO2 in geothermal wells. So it's something currently business currently under development. And as I said before, so we also try to bring to the geothermal market so what we call integrated drilling solution, but within a let's say adapted way to the geothermal market, so meaning that can be really competitive for the geothermal market. And finally, we have the last pillar that is call it new energy, and Miklos talked about it, lithium, so lithium batteries. So Schlumberger is involved in the development of lithium battery now, and also hydrogen production. So that was a short introduction of Schlumberger and this new trend that start mostly this year, beginning this year. And then, so I will be open for your questions during the panel discussion. Miklos, if you want to take the hand. Hello?
Yes, thank you, Damien, for this presentation and also pointing out of what Schlumberger is doing in the geothermal business. And we know that Geothermex is existing since 40 years in the business and is producing engineering services for all over the world, especially for high enthalpy fields. And I would say that Celsius is also a very motivating project addressing shallow geothermal, which is I think the future in densely urbanized environment and the new construction buildings. Yeah, well, I would say, well, there have been no questions so far here, and then there are people who raise their hand. Whether we can, in that case, I will give the floor to Eric L'Autre to make his presentation from the perspective of an oil operator. And I think we will take the questions later at the end of the three introductory presentations. So please, Eric, the floor is yours. How can I do that? Your microphone is shut, I think. No, we don't hear you. Some technical problem we have. We don't hear Eric. We see your slide perfectly, but we don't hear you at all.
Hear me?
Now, yeah, we are back. Okay.
Yes, Miklos, can you hear me?
Yes, I can hear you.
Fine. Okay, can you see my screen?
Yes, we can see your. I can see your screen. It's perfect. Please go ahead.
Okay, so I guess we can start. Sorry for the inconvenience caused. So, okay, my name is Eric L'Autre. I'm a production engineer with extensive background in reservoir engineering in the oil industry, in big companies and smaller companies. I'm currently working for an oil operator in France. The name is Vermillon Energy. All right, so what I wanted to give you today is a perspective on the lessons that we are learning in France related to our geothermal activities that are a bit unorthodox, I would say. And I want to thank the European funding on the MEET project for giving us this opportunity to do this work. Okay, I'll give you the context very briefly. In France, I'm calling it a laboratory for technical and regulatory potential pivot to geothermal energy. The reason is that we have a small but present oil production with a number of fields and many wells. We also have a known end to our business because there is an oil ban that has been passed recently. That means that in the next few years we will have to shut down production. So oil operators have to find new businesses. When you look at the energy landscape in France, electricity is largely decarbonized thanks to nuclear. So there is a shift towards heat, really, when people talk about energy transition in France. And the final point is that we have favorable geothermal gradient, be it in the Paris sedimentary basin, in the Aquitaine basin, and in some of the volcanic area in the center of France or the Rhine Graben. So really, it's a nice landscape to watch to see if indeed the oil and gas operators, be it the big ones like Total or the smaller ones like us, will and can pivot to more geothermal activity. I'm moving the slides. The next message is really that the way we are doing it at Vermillon is we are testing the options. The slide I'm showing here displays a number of data. On the message really is that we are producing plenty of water. I'm giving the example on the bottom left corner. It's a typical oil field producing in France. It's been producing for 50 years. It's producing at 97% water. The oil gradient that you see on the chart next to it shows that this is a normal geothermal gradient. About 30 degrees per kilometer. So the water down there is pretty hot at about 110 degrees C. And the final chart shows the cross plot of water rate at surface versus water temperature. We have wellhead temperature. We have wells well temperature as high as 95 degrees C. Yeah, so there's plenty of heat available. At the moment, it's pretty much wasted. It's reinjected in the oil and gas, in the oil wells, in the oil fields. So we are doing two things. We are leveraging on our infrastructure, in order to produce low geothermal energy. And in order to do that, well, there's a huge effort to map our resources, map our neighbors' need. When no one needs heat next to us, we try to bring new business in. So all of that results in a number of pilots to try and use the heat either directly or to produce electricity. And I'll show you an example of that. Also, we are looking at the conversion potentials, knowing that by 2040 we must abandon oil wells. There is a driver for us to defer abandonment cost if we can use those wells for geothermal activity. Yeah. So those testing options allow us to better understand the geothermal business, its opportunities and threats. So this is a really practical experience at little cost for us. Let me give you some examples. The next slide shows the next slide. Yeah, okay. The next slide shows an ongoing heat co-production pilot. So it's a place where it's facilities where we do produce both oil and heat. The schematic there shows that there's 4 producing wells. They're producing oil, gas, and water, mainly water actually, and we have 3 injector wells. After separation, the injection line runs to the injector wells, obviously, and the project is about installing a heat exchanger on the injection line to serve a high school. You can see there the temperature at the heat exchanger is expected to be around 60 degrees. So this is enough to provide some of the heat capacity that is required. I'm showing you a map of the location. You can see the oil platform at the bottom of the picture on 300 meters north, the high school. So there will be a 300 meters long pipe to connect the heat exchanger on our site to the end user. And this is a schematic view of the heat exchanger on our oil site. It's a bypass on the injection line, really. In terms of impact, so it might sound, the numbers might look trivial, but this is the first step for us. This is a way to learn the business again. So it will deliver 800 megawatt hour per year. The benefits really for the end user is that almost 100% of its needs are covered, and the reduction of CO, well, it reduces by almost 100% its CO2 impact. It's about 200 tons per year. Again, it does not go without challenges. They are the classical, geothermal subsurface challenges, the thermal interference in the reservoir as you inject a colder water, the scaling, the injectivity risks. There's also, I'd say, issues or challenges that are related to the fact that we are co-producing oil and water. One is that essentially your long-term thermal resources is dependent on the Brent price, because your geothermal revenues do not offset your oil producing OPEX, mainly electricity. There's the issue of the load factor of the heat. High school is used a couple of months a year on the not in the evening, so you don't have a huge energy intensity there to offset your cost. And then there's the whole issue of balancing the oil production optimization, which is usually producing more oil and less water with delivering the heat that you promise. On top of that, there are regulatory challenges because essentially in France it's not co-production is a bit of a gray area, and there were a number of environmental challenges because this zone is really a sensitive zone. But nevertheless, we are close to establishing this geothermal project. It will be done in the next few weeks. Really, it will start. So this is an example of a project in the southwest of France. I just want to share with you the classic. If the slides move, yeah, okay. A couple of technical points, but I'm not going to expand on that. The usual thermal modeling that requires some complex workflows. We're talking about surface thermal modeling, well modeling, reservoir modeling, all of that linked to a number of assumptions around end user heat needs that depends on the seasonality and all of that. So this is a rather complex thermal modeling. We don't have all the tools, so we had to do a mix of known tools and some handmade tools. Also, we had to acquire some temperature data to calibrate the well and the reservoir models. Something that is classic in the geothermal industry and less so in the oil business is having to deal with temperature in the reservoir. So this slide shows the modeled change in temperature in the reservoir at 3,000 meters deep as the injection cold front progress through the producer. So this was a key de-risking activity for us to understand the long-term thermal impact in the reservoir on the long-term resources. So I'll conclude on this oil co-production project to share some of the ongoing and executed projects. As you can see, we have a number of diverse projects ongoing. Tomato greenhouse is currently using our heat. An eco district is also using our heat. I've talked about the high school project and a number of other projects, one on algae farming and one on district heating are also underway. So we try to expand and to scale up to our entire portfolio. So we've talked about direct use of heat. I want to talk about the use of heat as in terms of electricity production. Electricity production is indeed often used only with very high temperature resources. People think about salts or other projects like this. The question that we're trying to solve with our partner Enogia here is whether we can use or produce some electricity at a lower temperature range. We've installed this machine here at one of our wellhead in the Paris Basin. The wellhead temperature, the fluid rate, the fluid temperature is 90 degrees C. The rate there, you can see it's about 21 meters cube an hour. And by design, we expect to produce 16 kilowatt of power. The tests are actually ongoing. It only started a few days ago, so this is really new data. I think you are the first one to see those, and the chart there has been recorded just a couple of days ago. It's under optimization, but at the moment we are currently producing about 13 kilowatt of electric power. To give you again the context on the impact, It's about 10% of the power consumed by our downhole pumps. This will be confirmed, in terms of seasonality, night and days, winter, summer. It will be confirmed in the next few months. Our driver there is not so much to export or to sell electricity, unlike what we're doing for heat. The driver there is self-consumption to reduce the electricity OPEX, which is one of the largest for us. So I will just conclude with a couple of take-home messages. My learnings. Heat co-production is in my view, a win-win first step. Regulatory enablers are needed. Of course, there are many synergies with oil and gas. Heat co-production is, however, limited to only a few facilities that are close enough to the customers. I'm not certain it is a game changer at EU scale. Also, in terms of oil and gas conversion, I think it's more likely to be the exception than the norm. There are a number of issues that we can talk about. One feedback from the people that we are meeting is that they really need to be addressed to address both. We need to address both heat and cold, for project to go on. Now, in terms of the role of oil and gas, and I'll conclude on that. Oil and gas players have been investing, quite massively recently in many renewable energy, but not the geothermal energy. And it seems that the main blocker is scalability. I guess we'll discuss about that, and there will be questions and opinions about that. So indeed, we need to think about big portfolio to get the profitability. My view also is that it requires the oil and gas industry to shift from a global commodity environment, where I, as an oil producer, I guess I don't really care who is my customer, to a mindset where I do care who my customer is, and actually my customer is my operations neighbor. Yeah. My view is that geothermal is a unique bridge between the traditional oil and gas geoscience on the drilling skills towards clean energy. So this is something that oil companies should leverage on. And the final point is that I think it could be seen as a valid hedging strategy for oil and gas, because the local market with a number of with set prices is a good hedging against fluctuating global oil prices. So I encourage feedback or questions or opinion on that from my oil and gas colleagues, and I will conclude on that give you back the mic. Thank you.
Thank you so much, Eric, for this presentation. I have here a bunch of questions. As I said, we will take them at the end of the introductory speeches. And that way we can motivate also the discussion. So I would like to invite Alberto Gentile, who is the Deputy Director of ES Geothermal, to give his vision on from a geothermal electricity operator's view on this synergy between oil and gas. Yeah. Albert? I think a priori we have some technical problems. We don't see you, we don't hear you.
Miklos?
Yes?
You hear me?
Now I can hear you, and I see a coronavirus.
Can you see
screen.
me?
I don't see you, but I see your screen. I see your screen with the prevention of coronavirus.
Okay, so maybe it's not. Okay, sorry, I have a problem with internet, but
yeah,
so, I was obliged to reboot my computer.
Okay.
So I try to share my webcam, but I don't know if you see me or not.
We don't see you, but we can hear you.
Okay, so maybe, sorry, I will try again last time to share my webcam, but it was working a few minutes ago. But otherwise, I will speak without the way. It seems that the internet is not very good. So, okay, so I will start, and maybe maybe you see me now, no?
Yeah, it should come slowly.
Okay.
We
So I
see
will
a black.
introduce
We see a
maybe I
black screen.
myself.
We see
Black screen. I can see me, but on the screen, but
maybe
okay.
it will come slowly.
Okay, so I will start. So
Yeah, I
thank
suggest as you don't have any PowerPoint to show us, I suggest that you give your view orally, and then we can go further to the discussions.
Okay, good. So first, I would like so my name is Alberto Gentile, as you mentioned. So I'm geologist and been working for EGEC for now 7 years. And today I will try to speak about 3 main points. I think I will speak about expertise and know-how and technologies between oil industry and geothermals. My second topic will be how we can use oil reservoir for doing geothermals, and Eric speak a bit about that. And maybe the last topic I will speak, it's about the main advantage of geothermals. But first, I would like to make a kind of transition, because Damien spoke about Schlumberger, and Schlumberger team and company was born in Alsace, where we are operating exactly in the field where we are doing today, geothermals. So in the past, it was a huge oil field. Marcel and Cora Schlumberger, they did the first electrical logs there. It was in 1927. And then there is a huge development for oil in this area. And because of oil, we learn a lot. And then we did geothermal. And we have a plant today, which is, the name is Sul-Sulphore, which is operating and producing geothermal energy and electricity to the grid. So Schlumberger somewhere was a part of this transition, because thanks to their development, we collect many data, and then we know the underground, and we did those geothermal projects after the oil, but there is a kind of genetic relationship between those. The second synergy that's here also, it was mentioned by Eric, and also I am the coordinator of the MIT project, where Eric was presenting some results. So we're also very closely related with what is doing Vermillon today in France, and I will speak more later. So first, I would like to mention that oil industry have a strong expertise and also technologies and know in many geoscientific and technological fields, in geology, fluid geochemistry, reservoir, drilling, stimulation, many things, modeling, also simulation, downhole pump technology as well, packers. And in geothermal energy, we are using some development which have been done in oil industry. For instance, for our side, we use from decades now, because we are exploring fractured reservoir in basement rocks, in crystalline, we need to know many information about the fractures. So we are running bore image logs, either acoustic image logs, either electrical image logs, and we are able to know at depth what is the orientation, what is the depth, what is the deep of various fractures, because it's very helpful for us. We need to, for instance, to set the second well, so we need to know how to organize a fracture in 3D. And based on those technologies developed by our industry but used in geothermal, we learn a lot. Second kind of application we use, which have been transferred from oil industry to geothermals. For instance, we did also a lot of work recently. We did a 3D seismic campaign in northern Alsace. So roughly we collect data over 200 square kilometers on surface, and we map a large area for targeting fault. We are in a Graben system, so the target was to map a normal fault, because the fault for our reservoir, and we need to know much more information from fault based, because in the past we used old vintage 2D seismic data, and then we decide, because we know the complexity of the fracture system at various scale, we decide to make this 3D survey for geothermal energy, and I think it was the first one in France and probably one of the largest in Europe. And now we have a large data set of fractures and faults which have been mapped till the top basement, because our resource, geothermal resource, in the top basement. So we learn a lot also in that case from oil industry to geothermal by using this 3D seismic survey. Another thing which is also useful, and was more recently, we drill a well close to Strasbourg in Kirch, for instance, and we use for the first time MWD during drilling. And for instance, it was very helpful as a geologist to get the camera in advance. You're not obliged to wait, I would say, standard geophysical well logging. When you finish one section, you can get some information about the gamma ray directly during drilling operation, and then you know where you are in your well. And it's very helpful to have advanced technology like that for geothermal energy, and we use that now in new wells. Obviously, we know that some technology are not, I would say, yet adapted, because generally geothermal, we are hotter, we are very saline, we are deeper, and then the completion, the size of the wells are also different. So there are some maybe some adaptation to do from oil to geothermals, but it's also the reservoir we are looking for. We are working in EGS reservoir in non-geothermal system. We are dealing with granite. It's not, I would say, standard. Granite is not a standard reservoir for oil people. Even there are some oil in granite in China or in Vietnam, for instance. But we can see that there is a huge potential to transfer expertise, and technologies, and then synergies from, I would say, oil to geothermal. So the only, I would say, limitation I can see from geothermal, it's the cost, the money, because, for instance, geothermal projects generally they are designed for 20 years or more operation, and then the money is coming after this long period. In oil industry, I assume that it's shorter, and then the business is not the same. It's faster in oil and gas than geothermal, and the price also of some services generally are very high. And as you know, a barrel of oil is not the same price of a barrel of hot geothermal water. So we need to lower, if we want to use much more, we need to lower the price of some servicing or some things which are, I would say, important for geothermal development. And maybe the last point about those technologies drilling. Also, we learn a lot also from directional drilling. For instance, in our wells, we are looking for vertical fracture, so we need deviated well. So we need to have all the equipment, the technology to drill in, I would say, highly deviated, even horizontal wells that have been done by Miklos in Paris, for instance. And then also technologies is a real first message. We need to try to fill the gap between oil and gas and geothermal, to use and to adapt those technologies to our site. My second message is about how we can use, I would say, geothermal energy and oil, kind of co-production, to do more energy. As you know, Eric mentioned that a few minutes ago. We have a EU project, the name is MEET. I am the coordinator of that, and when we set the project with Eric, we decide to see how much energy an oil well can produce. We know that it's not the same range that hot, very hot, I would say, volcanic system, but in some reservoir like the Basin Paris or the Bordeaux area, we can find water around 70 to 90 degrees C. And with this kind
I believe we lost Albert, so I don't know whether I can finish his ideas, but in general, what he wanted to highlight, that geothermal has been using a lot of oil. Albert, we lost you.
Yeah.
And I wanted to.
Okay, sorry.
We lost you where you were. I mean, about 2-3 minutes before.
Okay. So I was speaking about. Did you heard about 3D seismic when I spoke about 3D seismic?
Yes, it's about there when you were speaking about exploration.
Okay, so I was mentioning that we did the 3D seismic survey, and then we learned a lot about the fault system and for targeting new projects, and for instance with more wells, with doublet, things like that. And also what I was mentioning behind, it's also for drillings. We learn a lot from oil industry that we need to have directional or to have inclined wells. And because we are looking for fractures and vertical fractures, we need to have inclined wells. And we learned that directional drilling are very helpful for us, and it was also applied by Miklos in the Paris Basin. So many technologies, methodologies, know-how coming from oil industry can be used for geothermals. But what I was insisting at the end of this part is the main limitation is the problem of the cost, because generally geothermal project, for instance, business plans, typically we need 20 years or more. Geothermal is designed over this period to be viable economically. In oil business, it's shorter, and then we need to find, I would say, how to lower the price of, I would say, some oil services for us, because we cannot reach some, I would say, economic threshold. So it's very important to work on that, and I think Damien mentioned that to try to go in that direction, and could help to develop also more the geothermal projects.
Yeah. Well, Albert, thank you,
yes.
Thank you so much. I would like to if you have one more idea, just to express it, because we are going slowly to run out of time, and I have here maybe 20 questions we need from the audience. I would like to address them, and then if you have only one more idea, so before we go to the question and answers and discussions.
So maybe I can say one word more.
Yes, please.
Yes. So what I would like to say, that I was speaking mainly how we can transfer things from oil to geothermals, and also one message also I would like to give is also the geothermal also can bring a lot to on the opposite to oil, because we are low CO2 emission, we are clean energy. There are also, we can do a lot of for people locally. Heat, it's a local energy. And think for the also acceptability of the project, it's also a good message that people from oil are going in direction of geothermal people. So maybe it could be my last message, less technical, but more about acceptability and how to develop more projects close to the people.
Yeah, thank you very much, Albert. Well, now I would like to all speakers to come on board, and now we can see you finally.
Okay, sorry.
Yeah, to come on board, and we should address the questions. We had one question from Antoine Damore. Why Schlumberger chosen direct heat with shallow geothermal rather than electricity creation, deep hot wells? Is Schlumberger expertise not more leveraged with deep wells?
No, that we are interested in geothermal in general. So it was just a project developed by a team. They studied, in fact, deep and shallow solution. And okay, finally they found really an interest in this solutions in this specific market, in very niche market, if I can say, of a certain size of building campus that are not distributed, not individual houses, for which there was no solution yet, not a very good solution yet. So they decided to focus on this project now, but we have interest in deep geothermal too, and could be that we develop also other solution project for deep geothermal in the near future.
Yeah, I have another question for you, Damien. Why CO2 as a carrier fluid in geothermal project? Is Schlumberger in contact with geothermal fluid group of EGEC, Martin Zar, that have been worked for some years on the topic? It's a question coming from Frédéric Bunot.
Yeah, sorry, I don't know regarding the contact of Schlumberger with the company. I know because I've been directly in contact with the people developing this domain of CO2 capture in geothermal projects. So I know they already did projects. that the equipment have been developed for. But then I don't know then is the connection with this specific company. I'm sorry.
Okay. Another question I have for the floor. What is the impact of licensing and permitting in the process in terms of the cost of a project? This is for, I think, all of you and all of us, because we are all involved in some way. I think Albert, Eric, and myself, my company, in this permitting and licensing.
So maybe I can say some word for France, what we are facing. So licensing, so there is no, I would say, cost associated to licensing directly. The problem is the procedure are very long, so we lose time. For instance, we did the project in Wittelshofen, which is close to Source, some years ago. We exploit the power plant now for 4 years, and we still not have the concession, that means the right to exploit this site, and we are exploiting permanently for now the last 4 years, because there are not enough civil servants, I would say, at the ministry, the French ministry, because people, they have no time to go into the dossier and to give all the formal authorization. So the problem sometimes is more the time than the cost itself, but time is money. But so sometimes we reach, because you have a license for some years, and because the procedures are very long, sometimes you could lose your permit because I would say administration is too late, because there are less and less people in administration. So it's one of the problems we have, I would say, in France.
Yeah, I think our taxpayers' money should be used better by the government in order to, if they want in their politics to encourage geothermal, to accelerate the files. And this is a problem. We see it all over Europe. Well, I have another question for all of you. What European policy support do you need to increase the share of geothermal in your businesses? Well, like, maybe Eric could answer that. He's an oil operator.
Well, in France, the energy around geothermal by the oil companies is somehow motivated by the ban on oil. I don't think this is something that should be scaled up at European level, to be honest. Rather, I think there should be initiative to encourage oil and gas companies to invest, rather than punishing them by stopping their activity on hoping that they are forced to move into geothermal. You can think about tax incentives, anything that can help investment. One thing that we see is that at the moment, investors are flying away from the oil and gas sector. So it's getting money for your for your oil and gas investment is difficult. Something like a CO2 tax. Again, this is my personal view. It's not necessarily my company's view. Something like a CO2 tax, the way it evolved, there's probably a balance whereby you support geothermal energy without compromising other sectors. That's what I can say. One thing I'd like to mention as well, if you allow me, on the previous question, one on the licensing. One idea I read from Marit Brommer, the former head of International Geothermal Association, is the idea of licensing rounds for geothermal licenses. This is something that's very common in the oil and gas industry, of course, and it allows a very useful competition between companies, and also some planning, because you have licensing rounds happening every 2, 3 years, 4 years, 5 years. So this is an idea that she's through, which I think is worth thinking about.
If I can say maybe a word about the political support for geothermal, to what I observe in the different countries in Europe. In my opinion, there is somehow a disconnection or in between the political support or the incentive plan with the let's say project development time frame. So we see like in Germany or in France, or so the incentive plan is too short or varying too fast, or while a project need like especially the power generation project needs 6-7 years to be developed. So if you change the incentive plan every 2 years or reduce, change, or whatever, so it's not aligned with the life of the project. So in my opinion, incentive plan should be put in place and be stable for a good period of time for the developers really to have a good vision. If things are changing in a time frame that is not online with project development, in my opinion, that creates many issues.
Okay.
Maybe if I can add something, Miklos?
Yes.
So in France, the example of France, today we have no more feed-in tariff for electricity.
Yes,
so
that's a bit.
We cannot do any more electricity project, but there are a lot of helps for heat. But we know that the heat, because generally the comparison is done with gas price, as the price of gas is very low, our heat projects are not economic. So somewhere we are killed by electricity, and we are killed also for the heat. So we need to be clever. We need to make some co-production, heat, electricity, maybe lithium to be economic. But I agree with what's saying Damien. The time frame of with regulation or policymaker is not the time frame of a project. We start to think about Rittersaffen in 2004, and we opened the plants in 2016. So we need 12 years between the ID and to the real operation to do a project. So we need at least 10 years when we have a big project like that. So if we change the rules every 2 years, well, we are dead. So we need some stability in the rules.
Yeah, exactly. Yeah, investors need to see a stability, otherwise they don't go.
Yes.
I agree with you. Now low gas prices are not very much motivating for the heat prices, but this is not going to be sustainable. I mean, as what we have learned, and as I said in our introduction, we have to go back to the ground, to the basics of our life, and use our in-place natural resources. But of course, every time when we are speaking of a heating company or we are speaking of a developing company, it's the business model which prevails, and the regulatory model. And I agree with Albert. Our project, which was let's say we have get a lot of inspiration from the oil industry by drilling subhorizontal wells in France for geothermal. From the idea, we started thinking of it in 2004, and then we have achieved the project in 2018, and it has put in service in 2019. So I mean, it's a very long run project, and sometimes during this period, companies may disappear. I mean, who had the idea disappears, or the regulator just doesn't want, or the municipality changes. Because we have to stress also that all our geothermal projects.
In the period, you have 2 to 3 political actions.
Yeah, and then you have elections, and all our geothermal projects, especially those who are heating projects, are very strongly motivated by the community and by the local municipality. And if a project will from the idea, from pre-feasibility to permitting and commissioning, it takes 8 years. Then it's unsustainable, because the municipality in place after the 6 years will say, I no longer want geothermal projects on my backyard. So it should be a policy which should be strongly encouraged by the government and imposed by the government. But the positive thing in France is that now local municipalities and people they are obliged to study for every new public building renewable energy solution. So they need to look at geothermal, to solar, to some sort of heat pump. It depends on the size of municipal building. So this is an obligation. But anyway, it's still becoming a nightmare getting to permitting. Now I have another question to Eric. Could heat be extracted from the oil rather from the water, as it would not impact on the reinjection temperature? Or are the flow rate or the temperature of the oil not favorable? That is a question coming from Sebastian Daniels.
Okay, well, so typically oil and gas, oil on water flow at surface at the same temperature. There's, as I said, there's far more water than oil. I mean, if he's talking about an heat exchanger on oil rather than on water, this is not something that we have thought about. Oil has got a number of issues, and you want to stabilize it, store it, and sell it as quickly as you can. So that's not something that we have looked at.
Okay. Thank you. Now, another question. I think this you have all learned about the EVER solution of the closed loop by interconnecting multilaterals over a certain distance. They have been awarded. They are one of the companies who were awarded of the European Geothermal Award this year. What do you think of the future of this technology from the oil operator perspective, because this has been achieved with the oil and gas geosteering means and drilling means, and from the geothermal operator perspective?
Maybe I could say something. They are thinking. I could say something from geothermal point of view. So for us, which is obvious that we need to reduce the price of drilling. If we are not reducing the price of drilling, we will be not competitive. So we need to find solution, innovation, which allow to seriously reduce the price of drilling cost. So it's the first point. So if this technology is able to do that, why not? The second point I have to mention as a geologist, it's quite difficult to find area without any, I would say, fracture, fault, porous zone. So to make tubes in the rocks, probably it works, but we need to select in which area we would like to do that, because geology is not, I would say, homogeneous, isotropic. Generally, it's heterogeneous, complex, and then to make several wells, horizontal wells in the same rocks, we need to be sure that we have no leaks or no connecting fractures, things like that. So there are a real challenge also in terms of resource, but I would say, why not? We need to have demonstration project and to show that it works. We are still open to see this kind of technology from my side.
Okay. Thank you. I have another question to Eric. Are any of your projects competitive economic?
So the answer is that it's not their purpose. I mean, until now, I mean, so there are currently two projects where we are delivering heat to customers. Those were not commercial projects, so there's no question on that. The pilot that I've talked about with the high school is a pilot project under the umbrella of MEET on Europe, whereby we are actually looking at the conditions where it can be commercial. As a pilot, and this is true also for the turbine that delivers electricity. As a pilot, the intention is not to make it economic. This is to validate or to unlock the technical issues. Yeah, that's why we have we are financing by Europe to work on this. So the answer is no, they are not, but that's not their purpose. No, our work is to scale them up and see whether they can be made economic at different scale.
Yeah. Another question to you: do you consider downhole heat exchanger type completions in your wells?
No, we don't.
Okay, thank you. Then, well, Schlumberger, I think I can answer that, but the question is, are you also involved in high temperature electricity projects, or the focus for you is only heat production?
No, we are involved in electricity production. So Albert is there, and we have worked on we have been involved on the Ilkirche project. We have been involved in the project of Van Roche too, and in many projects in Turkey for electricity production. No.
Yeah. You were involved in service providers. You were not involved as developers. In Celsius project, you are the developer.
In Celsius we are developer. Yes. For now we are not developer in deep geothermal.
For the low, but for the high, you are service providers, as you were.
Yes.
You were for the previous project.
Yeah. For now,
okay.
Maybe we can make a transition there. I can come back to the cost of the oil service company services for geothermal. There is something also that we need to understand is that in the oil sector, so when we drill wells, usually we are in a very large field and a large number of wells to be drilled. So then you already, let's say, reduce your costs with mobilization. So while in the geothermal, if you just have one doublet to drill, so for sure the ratio of mobilization with then the cost of drilling change. One point. So then that means that okay, even if on our side for sure we have to adapt our service to geothermal to be more competitive, there may be something to change there, that instead of every developer in the geothermal to work independently, maybe working as a cluster and how to say to mutualize the services together can help to reduce the cost. So when we mobilize equipment, so if we have 2-3 projects to do in the same area, so we will already reduce the cost. And another next step, so could be to change the business model, at not having the oil service company just providing a service that is very expensive, but maybe to be part of the development of the project. And in that case, we totally change the business model, and then we can bring the best possible technology in drilling, because it becomes an investment. It's not anymore a service. It's completely changing, and that's probably a way to go.
Yeah. Okay, well, thank you all the speakers. We still have 10-15 questions, but the webinar time is getting a bit over, and I think well, we have made a point on this topic today. Well, I was just before wrapping up, I was just repeating what Albert said, that the geothermal shares the technology from the oil and gas industry, shares the exploration and exploitation risks, and also methodology. And in order to develop as I understood from an oil operator and from oil service company, to develop geothermal, you need a significant portfolio of projects, and this is because of one barrel of geothermal water, you take only 1/10 of energy, like from 1 barrel of oil. And then, well, the access to the resource in terms of permitting and also incentives and regulations would be much more welcome. Well, thank you for all the audience. I see people already leaving. We had 180 people, now we have 90. I think people got the point from this discussion. I wish you a nice afternoon or a nice day, all of you, and looking forward to see you on future EGEC webinars. Goodbye.
Thank you.
Thank you, Miklos. Bye.
Goodbye.
Thank you. Bye. Bye.
Il n'y a plus personne?